Hello, everyone. My name is Marcelo Chang, and today I am going to be talking about my Eli project titled Exploring the Environmental Impacts of Data Centers through the North Hall Data Center. So let's get started. So to start off this presentation, I'd love to just go over a little bit of my process and timeline and how I was able to do a really cool project with the Northall Data Center. So I initially applied in spring of last year for just something around sustainable AI. I was really using AI a lot at the time, and the more I learned about it, the more I learned on the negative environmental impacts that it has from data centers. So I wanted to see if Eli could give me the tools for me to make an impact on trying to solve that problem, and luckily it did. So moving on to the fall quarter, I definitely had a slow start. I didn't really know where to begin. I didn't really know what to actually do within winter and spring quarter. I wasn't sure if I could actually make an impact somewhere because AI and this whole topic of AI is so large. How can I make this on a smaller scale to make an impact on campus at Santa Barbara? And my first idea was to create this DEAR framework, the Data Center Environmental Efficiency Rating, kind of similar to the LEED score, but based off of data centers only with five categories, and I would hopefully evaluate the North Hall data center, which is a data center on campus, and give it a DEAR score. But luckily, I was able to get in contact with the North Hall Data Center right at the end of fall quarter, and that idea was quickly shot down. And my mentor, John Waller, who runs the North Hall Data Center, proposed a project for trying to switch off critical power onto non-critical power, and that's what I worked on in winter quarter. I was doing a lot of stuff with them, and then spring quarter was time to actually make structural changes from the recommendations that I made. So pretty cool. But moving on to my mountaintop goal. Again, I really want to base this project around sustainable AI and look into ways that as a society we could implement in a data center operations to make AI just more sustainable as a whole, because in the coming years, the amount of AI is going to be used is a lot more. So I really wanted to find a way to do that and also see if we can actually find some of these ways and apply them to some of the data centers on campus so we can make an impact at UCSB. And moving on to my SMART goal, by June 2026, I will have analyzed 62 cabinets within the North Hall data center, and based off of the cabinet's criticality, number of critical devices, total space, and power use, I will identify 10 cabinets to be transitioned from critical power onto non-critical power with the goal of reducing the critical power load by 30 kilowatts. And this right here on the left is a photo of where the North Hall data center is. I know a lot of people don't know that, but it's pretty cool. And actually, a little fun fact is that the two hills that you see that are to the left of North Hall in between the bike path are actually water coolers, water tanks. So that's pretty cool. And also, this is a photo of a cabinet with a server inside of the red oval. So I'm sure a lot of you guys are wondering right now what the difference is between critical and non-critical power. So I made these diagrams to kind of help explain that. So under normal conditions, power will start from the source, which is utility power, and then flow into the UPS or uninterruptible power supply, which then gives the server a stable power source while also keeping the batteries charged. But if power were to go out, that means utility power is fully cut off from the system. So, meaning that the batteries are now the main power supplier. So, for a critical system, they have a backup generator that starts up while the batteries are supplying power. And then, once the generator is up and running, it provides the entire system with a stable power source. So, even if power goes out, systems on a critical power system will not go offline. Whereas non-critical, they don't have that backup generator. So once the batteries are drained, then the system will shut down. And the key idea behind my project is determining which cabinets truly require that generator back power and which ones do not. An example of a cabinet that does require critical power would be one with a server that is connected to the 911 system within the police department. So if power were to go out, we don't want that system to shut down. We want it to stay up and running. And that is an actual server inside of the data center. So that's pretty cool. So for my project itself, I began with an Excel phase to kind of gain a general understanding of the North Hall data center layout using the OpenDCIM database. I analyzed 62 cabinets and I identified if the cabinet was using critical power or non-critical power. And if the cabinet was on critical power, then I would determine how many of those devices inside of that cabinet are critical and put that all onto an organized Excel spreadsheet. And then after that, I moved on to the second phase where I did a deeper dive into the cabinets individually. I went inside of the data center, opened the cabinets and based off the cabinet's characteristics, provided recommendations to my mentor, John, on what we should do next. And there was three main things that I was looking for when looking at the cabinets. The first one was if it's a critical cabinet with the fewest amount of critical devices, so then maybe we could relocate those critical devices into another critical cabinet with one, a lot of open space, and two, low power use, which then we would change that original cabinet off of critical power and onto non-critical power. And also a cabinet that is still drawing from a critical power source, and yet none of the devices inside of the cabinet are deemed to be critical. So then we would run a circuit and change it onto non-critical power. And with the recommendations, we were able to identify 21 cabinets in the data center that we are looking to change. And I'm very proud to say that within the past couple of weeks, we were able to get a circuit done on two cabinets, R6 R1 and R6 R2, fully removing them off of critical power and onto non-critical power, which reduced the total critical power load in a data center by 6 kilowatts. So why does this matter? So before I started the project, the total critical power load was about 194 kilowatts. And with the recommendations, the expected reduction is about to be 53 kilowatts, with 6 of those kilowatts already being reduced. And this is important because next year the data center is looking to purchase a new generator for the critical power systems. They could either buy a 400 kW generator, which costs about $280,000, or a 200 kW generator, which costs about 150K. And in order to buy the 200 kW one, we would need to get the critical power load to be at about 160. And doing so would save a lot of money, which could be applied to other sustainability initiatives, as well as with a lower critical power load. That means less diesel fuel needs to be inputted into the generator once power goes out, which would overall reduce the environmental footprint of the data center. So overall, what I learned on my lesson on leadership during this Eli project was the first one. Anyone can be a leader. I have absolutely zero engineering background. I've never taken an engineering class in my life, and yet I was still able to make a contribution to a sustainability project inside a working data center, which is something that is really cool and could not have happened without Eli. So I'm really grateful for that. And also, the second one is that baby steps really do matter. In my very last meeting with my mentor, he told me that data centers, there's so hard to make a great change. There's so many moving parts, so many things that can go wrong to where there is no final goal that they have. The only final goal is continuous improvement. And I think that can be said about a lot of things in life and something that I'll definitely take on for any of my future projects or just classes in general. So I really appreciate you guys listening for my project presentation, and thank you guys so much.